Hello students, let us discuss a first type of reaction that is known as combination reaction. It is also known as synthesis reaction. Because these reactions are used to prepare certain compounds from their elements, from their constituent elements. That's why this is also known as synthesis reaction. So first we try to understand what is this combination reaction. So the reaction where I have two or more than two substances, they combine with each other so as to form only single substance as a product. So I have two or more than two substances combine with each other so as to form only single substance as a product. That is known as your combination reaction. So I have A as one substance which combines with B as another substance and gives me AB as a single product. That is known as combination reaction. Now, combination reaction may involve combinations between two elements. It may involve combination between compound and element, and it may involve combination between compound and compound. So let us take one examples of each category where I have two elements combine with each other so as to form a single product. So I have carbon as an element combines with oxygen. It gives me carbon dioxide as a single product. Nitrogen as an element combines with hydrogen as another element so as to give me ammonia as a product. I have hydrogen as an element combines with chlorine as another element in order to give me hydrogen chloride as a single product. Then I have hydrogen to combine with oxygen in order to give me water as a single product. So in this case you observe elements are there, they combine with each other so as to give you single product. So combination may involve combination between these two elements so as to give you single product. Now let me take the second type of combination where I have a combination may involve between a compound and an element. So let me take sulfur dioxide as a compound which combines with oxygen as an element in order to give me sulfur trioxide as a single product. I have carbon monoxide combines with oxygen gas in order to give me carbon dioxide gas. So I have carbon monoxide as a compound combines with oxygen as an element so as to give me carbon dioxide as a single product. So this is where I have a compound combines with an element in order to give you a single product. That is known as your another type of combination where I have compound is combining with element in order to give me single product. Let me have a combination between two compounds. So I have ammonia as one compound which combines with hydrogen chloride as another compound in order to give me single product, that is ammonium chloride, which produces as in dense white fumes. So ammonia as a compound combines with hydrogen chloride as another compound in order to give me ammonium chloride as a single product. Then I have water as a compound reacts with CO2 in order to give me H2CO3, which you call it as a carbonic acid. As a single product. So we have fizzy drinks are basically a carbonic acid where Carbon dioxide is passed to water with high pressure and low temperature. Then I have water reacts with SO2 in order to give me H2SO3. It is called as sulfurous acid. So here I observe two compounds. Here I observe two compounds combine with each other so as to give me a single product. So these are the various examples or various types of combination reactions which may be possible between two element and compound and compound. Now before proceeding further to the different types of combination reactions, we need to know one particular thing that is called as activity series. This is very important thing. We call it as an activity series. So what do you mean by this particular term activity series? It's also called as reactivity series. So basically it's a series of metal which is arranged in decreasing order of its reactivity, that is called as your activity series. So the element or the metal which is most reactive, that is present at the top of the series, and the metal which is least reactive is present at the bottom of the series. So we have the series starts with potassium, sodium, calcium, magnesium, aluminium. Potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver, and I have a gold. So here this is a potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen. This is taken as a reference point. Hydrogen, copper, mercury, silver, and gold. So the metal which is present at the top is highly reactive. So we have metal at top is highly reactive. Metal at bottom is least reactive. And generally this series is based on the reaction of metal with either dilute acid or water. So the activity series is based on reaction of metal with either water or dilute acid like dilute HCl or dilute H2SO4. So how readily this metals displaces hydrogen from either water or acid based on that their position is there. So potassium, sodium, calcium, they are very violent. So they react very violently with water or acid in order to release hydrogen gas. Then as you go down, the reactivity goes on decreasing. Now copper, mercury, silver and gold, they generally do not displace hydrogen either from water or from dilute acid. So this series of a metal, we call it as an reactivity series. This will help us to predict about combination reactions, the ease with which an element combines with any other element, whether it is displacing hydrogen from acid or not. So everywhere in a subsequent types of reactions, we will be using this reactivity series for our reference. Thank you for watching.